Greetings and welcome to another nostalgic math chat. This is a video that isn't, it's not focused on solving a question from an exam, but rather it's kind of an offshoot from a video that was focusing on a particular question, and I spent a good 10 minutes just puzzled about how to launch into it. So I will put links for the respective videos. This one I will link on the question video, and on the question video I will link to this video, because I did promise that I would come back and hopefully have a bit more of a rigorous approach to the question specifically. Well, okay, I'll get into the specifics of it shortly. Well, I think shortly as now. So this is a question from the IEB May 2023 paper 2. This is question 8b. And so this question, the details are okay. We're given a circle with center O, and then we're told that chord AB is 8 units long. And then the third point is what was very interesting to me. So we were told that the perpendicular distance from the furthest point C on the circle to chord AB is 8 units. And that concept of furthest was very interesting, because I guess we could look at it as furthest as in maybe you measure from one end of the chord around the circumference to C, or likewise, the other end to C, and that point C happens to be the furthest that you can travel on the circumference so I guess the point that is equidistant from A and B on the circumference. So that's one way maybe that we could define what we mean by furthest, but maybe what makes more sense in this context is to use kind of this measurement that has been introduced, right? The perpendicular distance. So to kind of say, okay, C is the furthest away from AB, because in terms of perpendicular distance, that's the longest that distance can be. So what I'm trying to say is, if maybe I chose a point over here, right, you can see that perpendicular distance would be shorter than that perpendicular distance, for example. And if I chose something over here, right, that distance is shorter than that distance. So C is the furthest away from chord AB in terms of the perpendicular distance from C to AB is the longest that it could possibly be for this particular circle. And we're told that distance is 8 units long. Anyway, so I'm not concerned with actually solving this problem, because that we do on a different video. But what I was very interested in was, it kind of feels intuitive that, and I mean, the diagram also suggests it, but it feels intuitive that that perpendicular line that joins C and AB goes through the center of the circle. And as I was thinking about it some more, it kind of made sense that it should, because imagine if we did have a circle, inverted commas, where the furthest point, so if C did not go, English. So imagine if we had a circle, right, and we had this chord AB, and I'm just going to kind of rotate this diagram so that it works this way, because I don't know, that just feels better for my brain. So imagine we did have some point C, right, where the statement, the third statement there is true, that this perpendicular distance is the longest it could possibly be. Then our circle wouldn't really look like a circle anymore. It would actually look more like an egg, right? Possibly. So it would maybe be something like that, right? So that we could indeed have that being the longest perpendicular distance from circumference to this particular chord AB. So it does feel intuitive that in order for this guy to be the longest perpendicular distance, that line should go through the center. But I really did just want to kind of maybe show that with a bit of mathematical rigor. And I'm very curious. So this is kind of vulnerable because my brain does very usually struggle with things that look so simple, and sometimes even getting the intuition for those simple things is a struggle for me, and I end up really coming to understand why that particular thing holds through a very complicated process that people tend to look at and they're like, girl, you are overthinking this. So yeah, putting this out there is a bit of an act of vulnerability in that sense, where I feel like there might be some feedback of, why are you complicating this? But I think I'm ready to kind of hear like different thoughts about this. Do you think that this is straightforward? Is there a simple way to understand why this line does necessarily go through the center of the circle? Like, I can see visually that it should, but how would you explain mathematically why it does go through the center of the circle? So here's my jab at that. Let's do it. So I would like to just work with this problem with the chord being here instead of here. Doesn't change anything, shouldn't change anything really. So what I thought I'd do is I would put the circle onto the Cartesian plane. So here we go. It's drawing such straight lines. I really appreciate that app. Okay, so we've got, but maybe I don't want such a dark, thick pen. Can we do it with the pencil? We can. Okay. So this is the y-axis and this is the x-axis. And we are going to draw the circle of life. It would be so great if it could draw a perfect circle for me, but I should not be so lucky, should I? Okay, so this is ending up looking like the very egg I was trying to avoid. I'm going to try again, just so it joins properly at the top. That's my only ambition with attempt number 2. Okay, that's a bit better. Right, so let's just say this circle, we're just going to make it as generic as possible. X squared plus y squared is equal to r squared is the equation of this circle, right? And we have some chord AB, right? So AB is just chilling somewhere here, okay? And of course our center is at the origin, right? And let's just say that AB crosses the point 0P. Okay, right. And then we have, let's say, some other point C, right? And the coordinates of C are X and Y, right? And we are interested in the length, the perpendicular distance from C to the chord AB, okay? So we are interested in, maybe we don't have to do it dashed. Let's see if we'll get a straight line again. We kind of did, but it's overstepping. Okay, that's sort of okay, right? So that's the length that we're interested in, right? And we can see that that's a length that changes depending on where C is. So if C was here, then that length looks like that. If C was here, then that length looks like that. If C was here, that length looks like this, and so on, right? So it is a length that changes depending on where C is on the circumference, right? Okay. And if we're to, maybe I erase those two quickly. So if we're to make the problem even more specific, right, we can see that this length doesn't change, right? This length is always going to be P units, well, minus P, right? Because the chord is fixed wherever it is. So the distance from the chord up until the x-axis, that's going to be fixed for at least for the points on the circumference that we're interested in. All right, so we're not looking at a point on the circumference here because then we don't even have the perpendicular distance that we're looking for. So yeah, I would say maybe the points that we're interested in are somewhere from there to there, right? Because then we maybe even that's out of reach, but do you get what I mean? So for the points on the circle that we're interested in, that the highlighted distance stays fixed, right? What is actually changing is this guy, right? That gets longer, and then starts getting shorter, and so on, right? So so I want to get an expression for this length, okay? Right, and this is where we can lean on our trig, right? So trigonometry, we know that our trig ratios are defined as cos theta is equal to x over r, and sine theta is equal to y over r. Okay, and we need to kind of define that a bit more. So what is theta? Theta is the angle between the x-axis and, if we were to join O and C, right, that angle over there is theta. And then obviously this is our r, the radius of the circle. So our trig ratios are defined that way. And so x is the same as r cos theta, so the x coordinate is the same as r cos theta, and the y coordinate is the same as r sine theta, right? So x is the same as r cos theta, and y is the same as r sine theta. Okay, cool. And so the question becomes, when is this, well, no, wait, I'm not done with that train of thought. So that means that this distance over here, right, from C until the x-axis is given by the value of the y-coordinate, right? If your y-coordinate was 5, then you would know that that distance is 5, the distance from the x-axis until C. Or if your y-coordinate was 3, then you would know that that distance is 3 units. And because our y-coordinates for the points that we're interested in, right? Remember we said we're just interested in the points from roughly here to here. Those y-coordinates are always going to be positive. So whatever the y-coordinate is, that's going to be the distance from the x-axis up until C. So that means that this height over here is given by r sine theta. So remember, as C travels along the circumference, right, that means that this height is going to change according to theta, right, according to how big this angle, how big or small this angle is. So then the question becomes, when is this height at its largest? When is it its biggest? When does it when does it when does it hit its maximum, right? So R is fixed, right? R is fixed because it's in the definition of the circle. It doesn't change, right? But what does change as C moves around is this angle over here. When C is here, right, this angle has changed to this, and when C is here, this angle has changed to that. I hope that's vaguely visible, right? So the question is then essentially, when is sine theta its biggest, right? And if we think about, you could think about it in terms of the graph, you could think about it in terms of the unit circle or whatever, right? So if we look at the sine graph, okay, and specifically here we're looking between, let's just say 0 to 180 degrees, right? We know we're looking at an even smaller subset than that because we're not looking all the way from here to here on the circumference. We're looking at a smaller subset of that. But let's just say for simplicity, we're looking in the range 0 to 180. We know that that graph, so sine theta, sine of 0 is 0, and then it hits a maximum at 90. Oh no, maximum at 90, and then at 180, sine is back to 0 again, right? So smallest at 0 and 180, at least in this range, but then it hits the maximum at 90 degrees, where sine of 90 is equal to 1. So that means that this distance, no, not that distance, sorry, this height over here, r sine theta, is its largest when theta is 90 degrees, i.e. when C is over here, directly above the center of the circle, because that's when we have our 90-degree angle, right? And at that point, this distance is, of course, r, right? R sine of 90 is 1, r times 1 is just r, right? And that also makes sense visually because C is right above the center. It's connected to the center. Therefore, its length is going to be whatever the length of the radius is. And that then proves that if we have a point on the circumference of a circle, and that point is the furthest away from a given chord, right? And by furthest, we mean that its perpendicular distance from that chord is as long as it could possibly be, then what we know for sure is that if we draw that perpendicular line from C to the chord, then that line will definitely go through the center of the circle. So that's kind of how I thought about justifying this, right? Justifying that the line that goes from C to AB has to go through the center of the circle. When I looked on the memo, there wasn't any, I don't recall there being any explicit justification for it. So definitely not something that the student needed to have done, that you needed to have done before launching into solving the problem. But I think it's always good to question things that seem straightforward, things that we maybe take a bit for granted. And I am curious to hear your explanation for why this result is what it is, or what was your intuition about it, and how would you explain to someone else why this line from C to BA definitely goes through the center of the circle. Cool, I hope you enjoyed this, and I hope that we'll have more conversations like this, and please feel free to share maybe more questions that you have like this, where maybe someone is explaining something to you and they kind of glibly mentioned something as part of the explanation, but your mind kind of got stuck on that to say, well, wait, actually, is it trivial? This is a word that I discovered mathematicians love so much. Is it trivial? Is that result trivial? Or is there actually a bit of, like, how would I explain it mathematically? Is there a bit of a surprising amount of work required to demonstrate this result? Okay, I'm going to stop rambling. Cheerio.